everything works. Okay, I'm Cristiano Foderi, and sorry, and I'm here to speak about our experience in the rural area of Bolivia. We have this experience in the last years, and we have tried to rebuild a land use evolution using satellite imageries and the approach with the Google Earth Engine platform. So just a brief outline of the presentation. I will talk about the cloud-based computing and the integration with remote sensing. Some word about the study case, the context of the work of the project. The tool and the methods we have implemented to do this land use change evolution analysis. The results we have found, and some discussion issues, something to talking about of the results. Of course, we all know what the cloud-based computing is. Probably every one of us have to deal with this technology every day, such something like storage servicing or computational servicing are very, very common on any aspects of our life. So what's the advantage of this technology? Firstly, we have the possibility to provide online, on-demand, scalable imaging processes capabilities, allowing the processing tools to be more efficient, collocating with large image dataset among different servers. We can be totally independent from hardware and software need, hardware and software specific tool. We can be completely multi-platform, as we said. We have the possibility to rapidly integrate and develop new algorithm and processing tool to fit our needs, accelerating the technology transfer among all of the stakeholders. What is the relation with the remote sensing? This kind of service, this cloud-based computing service and tools, allow the access to over 40 years of satellite imageries, more or less with the daily update, allowing the access at more than 6-7 petabytes of publicly available geospatial data, considering both the geographical information and the metadata of this. We can have a comprehensive tool set to analyze this data, and we can implement scientific algorithm ready to use or with the possibility to create our own just to fit our needs. I've already said. So, just 2-3 words about the context of the project, of the work. The work is a part of a larger project carried out in Bolivia. It's a project that has the aims to analyze the natural hazards on the region of the Valles Cruceños. It's a region on the south of Santa Cruz de la Sierra, with the specific objective to identify and develop environmental quality maps and natural vulnerability, with a particular vision of the erosion map and soil degradation risk using the information carried out with this kind of work, carried out with this satellite analysis, integrated with the local community's perception of this vulnerability. So for doing that, we have developed an analysis of land cover evolution in the last 30 years in this area, using some reference periods, 2-year periods for each decade, on an area of about 15,000 square kilometers. Okay, which classes we have choose to select to use? We have choose to use these classes because are very, very functional to the project aims. We have discriminated between forest, dry forest, agricultural surfaces, shrub land and bareland, grassland and pasture, grass and shrubland, the urban surfaces and the water bodies, because they have a different response to the soil erosion. So we need to identify these classes for this reason. We have used a pretty common method, supervised classification, using something like a composite of 2 years of Landsat T1 image. Is not a properly defined composite. Is something like something more like a stack of 2-year images. We have choose to use the T1 product from Landsat just to ensure the geometrically accuracy of the product. So to resume the process, we have used the Google Earth Engine platform to load information from Landsat 5 and Landsat 8 T1 satellite product. We have set a cloud cover threshold at the 10% of the coverage, and we have produced 4 stacks of this image to use to train or model or algorithms with more than 3,000 of training points, of classified training points. We have used in particular a classification and regression tree algorithm applied with the training point at all of the bands, all of the information we have on this product, on this satellite product, to produce this full land use map. We have tested the map using a confusion matrix just to calculate the Cohen key index, and as you can see we have pretty good results going between the 86 and the 19% and the 90% of accuracy of the information during the classification process. Going deep in the results, we can see that the forest cover in blue during these periods is increasing without point. It's increasing in the last 10 years with a little bit decreasing of the red curve. It's a dry forest curve, and the purple one, that is the grassland and pasture. So is pretty is maybe more clear comparing the percentage of the land use in the different periods we have analyzed. You can see how the forest cover, starting from the 1987 and to the old period, go decreasing since more or less the beginning of the 2000, and then start to increase again. Increase again with the decrease of the dry forest in red. It is sensitive the decrease, and a little bit decrease of the urban areas, the grass and shrubland, and the grass and pasture more. So, going to the end of the presentation, some general consideration about the work. Of course, we have tested a very time-saving approach. We have more or less, we need more or less, less, not more. We need less than 2 minutes to carry out a classification for each period. So in 10 minutes, more or less, we can have all of the data set processed. No data has been downloaded, so everything was run in the cloud-based system, with a totally multi-platform approach, totally independent from the hardware and software we have, with some good performances of the CART algorithm. We have a pretty good performances between 87 and 90% of accuracy, with pretty unexpected results for forest cover. Why? Because this information is in contrast, partially in contrast, with the prediction made by several deforestation models, several famous deforestation models, and partially it's in contrast both with the information provided by the local communities. They have a different perception of what's happened. We have a decrease of the agricultural extension to have an increase of the forest cover. How we can explain this? Probably the main reason is the effect of the progressive abandon of the agricultural areas caused by the urbanization of the rural area of Santa Cruz and the urban areas in the Valles Cruceños, like Mairana, like Valle Grande. And what we plan to do next? We need to validate this process, starting from the real land cover in field. So we have to carry out some field survey and compare our results with the local communities, with the participation process, to solve some classification issues we have found. The more important are the confusion we can have between bare land and urban surfaces. This is more frequent on the Andes mountain. We have some problem to discriminate between forest and agriculture. especially when agriculture is a citrus plantation. It's very common in this area, and we have some problem in the discrimination of the water bodies during the dry session, that is the less cloud coverage. So, thank you.